Pre-flight 101, the course that will give you wings. 6. Performance and envelope limitations. 6.3. Limitations and envelope. Hello again, this is the last part of this section. In this section you will be taking a look at the different limitations we have to respect for the three different models we've been talking about. Limitations are numbers or parameters that give the safe values for operation of our aircraft. Operating safely means not surpassing these limits. Anyway, I've added a table with all the limitations from the three models to the download section, so you have them all together at the same spot, and that way it makes you studying easier. You can go now to the download section, print out the table, and that way you'll follow this lesson easier. Let's get started. So, these are the limitations for speeds in the Cessna 172 November, Cessna 172 Romeo, and Cessna 172 SP. As I always say, be careful with these numbers. The numbers that prevail are in your POH, in your Pilot's Operating Handbook. This is just a reference. This is just a general course. It's as accurate as we could make it, but difference can happen. Different countries, organizations can make their own regulations, and we don't want to go against that. So, as always, as a disclaimer, in case of any difference between these limitations and your limitations in your POH, the limitations in the POH will be prevailing, right? Anyway, the first speed we have is VNE, never exceed speed. In the older model, in the Cessna 172 November, it was 160 knots. However, in the Cessna 172 Romeo and in the Cessna 172 SP, it got raised to 163 knots. I mean, there was probably some kind of structural change for these 3 knots. However, as you can see, it's not a really big number. The VNO, structural cruising speed, is the speed we should keep in smooth air. Is the maximum speed we should keep in turbulent air, in air that is not smooth, right? When we're doing maneuvers, we should never attempt to do maneuvers over this speed. In the Cessna 172 November is 128 knots, and in the Cessna 172 Romeo and the Cessna 172 SP it's going to be 129. As you can see, it's basically the same speed. Maneuvering speed depends on weight. Okay, the more weight, the higher the speed we're gonna need for maneuvering, right? That's called VA. We can use it as turbulent speed. Anyway, it's not really a limitation. It's more like a recommended speed for maneuvering. It gives you the best handling capabilities of the aircraft at certain conditions. The big thing I want you to see here is that the heavier the aircraft is and the more powerful, the heavier it is, it's gonna be giving you highest values. So the Cessna 172 SP actually gives way higher values for VA than the rest of aircraft. So you might imagine that the Cessna 172 November has less control than a Cessna, has more control than a Cessna 172 SP. That's why the Cessna 172 SP needs more speed, because the surfaces are less efficient. Anyway, BFE, flap maximum speed. This is probably one of the big changes right here. 85 knots is the limitation for flap 10, and for the rest of the flaps in the Cessna 172 November. However, from that moment on, in the Cessna 172 Romeo and the Cessna 172 SP, the limit got raised to 110 knots for flap 10. Okay. This is a big change. However, I always encourage you to look at your instrument, green and white band. I also encourage you to look at your POH, like always, to check for these data. The maximum window speed Actually, this is really cool. What speed can I open the window in my aircraft? In this kind of aircraft, you can open your window at any speed, right? As you can see here, the never exceed the speed matches the maximum window speed. Right here, same, and right here, same. Okay, so these are the limitations for speeds in your aircraft. Now we're going to be taking a look at the limitations for the engines. As you know, we took the Cessna 172 November as a prototype or as a model that was fitted with a carburetor F-gas engine. The Cessna 172R Romeo is fitted with an injection engine, and the Cessna 172 SP is fitted with diesel engine. So here in this chart, we have the different parameters that we have to be taking into account for our limitations. So let's get started with this. Maximum engine power, as you can see, the Cessna 172 November is going to be 160 brake horsepower. The Cessna 172 Rome is going to be 160 brake horsepower, and the Cessna 172 SP is going to be 155. The big difference between them is the RPMs: 2000 RPM, 2400 RPM, 2300 RPM. Okay. They produce a fairly similar amount of power, but with different range of RPM. The CHT, or cylinder head temperature, is the temperature the cylinder should be at. The only measure that I could find in the manuals is 200 to 500 Fahrenheit. Couldn't find this indication in the Cessna 172 November or in the Cessna 172 SP. The oil temperature, one of the most important parameters. For me, probably the most important change is that in the diesel one, they actually give us a limit minimum temperature for starting an engine with this cold oil. This is going to be, as we talked about, in the fuel system, because for jet fuel produces paraffin when it's too cold. We don't want the fuel to become slushy, right? We want the fuel to actually flow. So if the oil is at minus 32 degrees and you start that engine, you're actually going to be cooling too much that fuel. So that's one of the principal differences right there. The oil pressure, also really important parameter. As we will see in the procedure section, we're going to be seeing how the first thing we're going to be looking at after starting our engine is our oil pressure. We need that positive oil pressure right off the bat after we start our engine. As you can see, pretty much the pressure is going to be basically the same. 100 psi in the Cessna 172 November, 90 psi in the Cessna 172 Romeo. The Cessna 172 Romeo is an injection engine. It's wanna work at higher oil pressure. As you can see here, the limit is a bit higher. Anyway, in the Cessna 172 SP, it's about 6 bar, 6.5 bar maximum in case of cold starts. If you multiply that by 15, you're actually gonna get values like 90. Okay, so the values from the Cessna 172 Romeo and the Cessna 172 SP are pretty much the same. Fuel flow. Well, I already explained this in the instruments section. However, the green arc for the fuel flow is not just the useful range, or it doesn't really mean that if the fuel flow is not in the green range, is not working properly. What it means is that if it's outside of the green range and your power setting is not too high, something may be wrong. Okay. Example: when you're on a takeoff with maximum power, you can expect higher fuel flow. So it's obviously not going to be on the green. It's going to be probably over the green. That is not bad for takeoff, but if you are in cruise power, and you're getting that gallons per hour over 11, that's bad. Okay, now the vacuum. We talked about it. We talked about the instruments we need vacuum to work. So yeah, basically minimum 4.5 inches, maximum 5.5. These are the American measures. They kept them this way. Yeah, it's just what you have to look for in your instruments. So these three parameters right here are appropriate for the CESSNA 172 SP only, powered by jet fuel. As you can see, the coolant temperature cannot be lower than 32 in the start, also because of the freezing. Okay, we want this engine to warm up before that engine starts. A normal coolant temperature is from 60 to 105 degrees Celsius. We're talking Celsius here. The coolant temperature is going to be that. So now we have the gearbox. We already talked about this. There is a gearbox connected to the FATEC that is going to change the pitch of the blade propeller to create the maximum efficiency. So that gearbox needs at least a minus 30 degrees and maximum 115 degrees because it has some liquid in it to work, some lubricant, and it needs to be at a temperature to be working properly. The minimum flight temperature is going to be minus 35 and minus 30, depending if you're in flight or you're in ground. As I said before, all these limitations are because of the fuel. Jet fuel is really susceptible to temperature, so we want to keep that jet fuel at the correct temperature range. So these are the limitations for the engine. Now, in this last section, we're gonna go over the limitations for weights. But in this case, I'm not gonna be wasting a lot of time here. The reason why is really simple. We've talked about weight and balance. You learn how to fill up a weight and balance sheet. So there's no point in me telling you the maximum weights. If you want to know the maximum weights for your aircraft, you should always refer to your manual and your charts. Okay? Because if you refer to this, the company, the regulations for your country might have changed, and that could actually create a problem. So when we're talking about the weights, this is just as an example. Okay, you need to be careful and look at your POH always, and always calculate your maximum takeoff weight, your maximum ramp weight, etc., with your weight and balance sheet. So we talked about this before in the halt section when we were talking about systems. Yes, baggage area 1 limitation is 120 pounds in all of them. Baggage area 2 is 50 pounds in all of them, and total baggage area is 120 pounds. So we cannot fit 170 pounds, okay? We can't. The maximum total is 120. It can be divided in between both, but the maximum is 120. Keep that in mind. Next thing is that in utility, okay, this works the exact same way. So it doesn't matter if you're working an aircraft that is in normal category or in utility category, it's going to be the exact same thing. Just wanted to comment that. Anyway, limitations. We have some more miscellaneous limitations. These are the last section for this lesson. We're going to be talking, for example, about the service ceiling. The service ceiling is what the manufacturer says that the aircraft is going to be able to climb to. Is the maximum altitude of the aircraft that the aircraft is going to be able to maintain a positive certain regime, right? A certain rate of climb. Okay, depending if it is jet or it is piston, this rate is gonna be different. CESSNA tells us that our service ceiling for the Cessna 172 November is going to be 13,600 feet. Yeah, you're lacking just a little bit of oxygen there. It's not too bad, but I wouldn't suggest to be there for a longer time. As you guys know, more than 10,000 it starts to be the non-safe area for flying due to the lack of pressure in the air that is going to push that oxygen inside of your body. However, your aircraft can reach that. In the Cessna 172, Romeo is supposed to be reaching 13,500. Okay. And in the Cessna 172 SP, as it is powered by diesel and more importantly by a turbo, it's going to allow you to climb to 18,500 feet. Actually 5,000 feet more than the Cessna 172 Romeo. Anyway, that altitude is probably not really safe either to be flying to. These are raw performances, which means that you should not rely on this when you fly there. From my experiences, aircraft usually don't climb that high. Okay. Usually the real performance is worse than that. And probably if you climb to 13,600 feet, you might be able to make it, but it's gonna take a long time, and probably your airplane is not gonna respond too good at altitude. So yeah, if you wanna try, maybe simulator is better for that. Anyway, demonstrated crosswind. The demonstrated crosswind is gonna be 15 for each. I said this thing here because demonstrated crosswind is not a limitation. They say this many times in the manual. A crosswind limitation is not 15. The demonstrated crosswind is the maximum crosswind they subjected to Cessna when they were doing their test flights. But that doesn't mean that that is a limitation. Okay, the limitation is set by your company or by your flighting office or whatever. However, if the flight engineers at Cessna didn't fly the Cessna for more than 15 knots, why should you? That's basically the point right there. The VSTOL at landing configuration, VSO, 33 knots for the Cessna 172 November and the Cessna 172 Romeo, and it's going to be a lot higher in the Cessna 172 SP because of the engine mount and the weight. So it's going to be about 40 knots. The VS1, of course, I have set this right there to mark that this depends on the engine, of course. A more powerful and heavy engine is going to become a higher stall speed, right? Same happens with VS1, stall speed at zero condition. It's going to be 44 for the Cessna 172 November and the Cessna 172 Romeo, and the Cessna 172 speed is going to be 48, so 8 knots more than with flap. So the point is, remembering these limitations, taking them into your mind, and if you get them asked, just answer them. Anyway, this was it. The point is that you remember these limitations in order to correctly operate the aircraft and to be able to recognize a failure quicker. I mean, if you look at your instruments and quickly realize, hey, that temperature shouldn't be there, that's too high, that's too low, it's going to be easier for you to recognize a failure. In any case, always check your manuals for the most updated and actual figures for your own airplane. See you guys in the next lesson. And don't forget to bring your airplane to class. We are gonna be finally learning how to fly. Stay tuned. See you out there.